My name is Naol Ketema, and this is Project 1.4, the ACES Christmas Tree. This project consists of 4 circuits: the RC oscillator, the 4060 frequency divider/counter, multiple LEDs, and the finished product, the ACES Christmas Tree. This project's primary component and main focus are the digital logic chips. The 4011 and the 4069 are the primary chips in this prototype. First, the 4011 is also known as a NAND gate, which has 2 inputs and has 1 output. In this case, the 2 inputs would be the gray wire and the 3030K fixed resistor. On the pinout of the 4011, green represents the input gates and blue represents the output. The red colors on the top right and bottom left corner represent the power supply and ground. As seen in the parts table, the RC oscillator is made up of one 9-volt battery source, a reset button, CD4011BE chip, CD4069BE chip, a 5mm green LED, a 330K ohm fixed resistor, a 47K ohm fixed resistor, and a 1 microfarad capacitor. The 4060 divider/counter can create an illusion of binary counting. This is done through the different time delays and frequency signals. The reason for the time delay is because each Q pin is equal to 2 to the x. This is because there are 2 clock pulses per second. As seen in the image, the numbers that divide the frequencies are powers of 2. This can be calculated using this equation. The built-in oscillator in the 4060 allows it to create a clock pulse to increase the counting. This makes 4060 chip a timer circuit because it uses different frequencies to create various time delays. The 4060 chip is a timer circuit because it uses different frequencies to create different time delays. The RGB LED allows for the counting of colors. This is what helps demonstrate the illusion of binary counting. This is why the 4060 can be highly applicable in devices that require accurate and consistent timing. If one looks closely at the numbers that are divided in each output, they are all powers of 2, as mentioned before. If for example, a 64-second delay is necessary for a certain device's function, the output pin that needs to be used is Q6 because 2 to the 6th is equal to 64. This equation can be used to determine the different frequencies of each output pin of the 4060 logic chip. All of the components that are shown over here interact together in order to create the oscillation, as seen before and as we can see now. The small orange wire, the yellow wire, the red, and the large orange wire connect each row of the connected LEDs to a frequency. This allows each row to oscillate at different time intervals. Here is the false state diagram to get a better understanding of how it works. Finally, the RGC ACES Christmas tree is built. It is made up of a 4060 logic chip, a special RGB LED that fades in and out as a result of a built-in capacitor, a printed circuit board of a 2D Christmas tree, a 3D printed star diffuser, a stand, a power jack, a 9-volt battery source, 2 conical compression springs, a 16-pin IC integrated circuit socket, and 32 LEDs that are built into the printed circuit board. The RGC ACES Christmas tree is the combination of the 3 prototypes that were made in this project. It shows how a logic chip such as the 4060 can have a huge impact in the world of electronics. Thank you for listening, and I hope you learned something.